Right. So starting the recording, I will be first of all looking at a quick recap of the concept of projections and component of one vector along another vector that we were discussing last time. So that is something quite critical. Okay. So let me start with quick review of the concept of projections that we saw as an application of dot product last time. So we saw that this is an application of scalar product. Just a moment, I will reshare the program. Just give me a moment, guys. Resend the assignment. I have already sent it on the group. Okay, I'll resend it again at another stage. So we saw last time that if we have two vectors, let's say A and B like this, which are at an angle theta, then dropping a perpendicular from A along the direction of B, this component is called the parallel component of B. Okay. And the other component which is perpendicular to this will be called the perpendicular component of B. So this angle is 90. So we saw that given two vectors A and B, in component form, we can express two things. This one, which is the component or projection of vector B along vector E. So we can express that as it will have a magnitude of B cos theta, and its direction will be along A's direction. So its unit vector will be A cap. So here B cos theta is calculated using the formula A dot B divided by mod A, and A cap is calculated by dividing the vector A by its own magnitude. Okay. So this is how we find this component, the one which is along the vector. B's projection or component along the vector E is calculated by using this formula in this method. And similarly, the other component, the one which is perpendicular, that can be calculated using the concept B perpendicular. This can be calculated. This is the component or projection of vector B perpendicular to vector E. So this is calculated using the formula. This is B minus B parallel. Okay. Or its magnitude is simply B sin theta, which can be calculated using the formula root of B square minus B parallel square. Okay. This is the magnitude of that projection, whereas this is the projection in vector form. Okay, so this was something very important that we learned last time, and because this is a little bit confusing, so I want to start off today by doing a proper revision of this concept with a couple of questions. Then we will move on to the assignment discussion, and then finally we will move on to cross product, which is our task for the day. Okay, so let's do an example of this. So we have a vector E, which is, let us say, I cap plus j cap minus k cap. And we have another vector B, which is 3i cap plus 4j cap. So we have to find E parallel and E perpendicular. That is the components of the vector E along the vector B, okay, and perpendicular to the vector B in magnitude only. In magnitude form only. Okay. And second, we have to also find B parallel as a vector and B perpendicular as a vector. These are the components of the vector B in, let's say, along the vector A and perpendicular to the vector E. Okay. In vector form. That is in terms of I cap, j cap, k cap notation. Okay, so start by working this out. This is completely based on what we discussed above. Okay. So try and work out this yourself. Okay, take down the values. Then I'll take you to the formula again once, and you can apply that directly over here. Okay. So just apply this concept now in this numerical question. Start with part A yourself. Anybody got the answer? Please send me the answer if you got it. So let's understand what we are trying to do in the first part. So in the first part, we have to calculate E parallel and A perpendicular, only magnitudes. Okay. So for that, we have to understand that if this is the vector E, suppose, and this is the vector B, suppose, and the angle between them is theta. You can see that the vector E I had given you was I cap plus j cap minus k cap. The vector B I had given you was 3 I cap plus 4 j cap. These are the vectors. So now drop a perpendicular here like this, and this component of E, which is parallel to B, this component is nothing but the parallel component. So this is the projection of E which is parallel to B, and similarly draw a projection like this. Which is along the perpendicular direction to this, along this direction, it's perpendicular. So this is the perpendicular component. It's like for xy axis, we draw the x component and y component. So वैसा ही है यहाँ पे, but instead of the x axis is the axis along which B lies, which is this axis. And instead of the x axis, you're taking the axis of B. Instead of the y axis, you're taking the axis perpendicular to B. So in this diagram, you can see that this is the component of the vector E, which is along vector B or parallel to, and this is the component of vector E, which is perpendicular to the vector B. So as far as magnitude is concerned, this is the magnitude of this component. That will be how much? That will be A cos theta. And by definition, A cos theta is E dot B divided by mod B. Where this formula is coming from? It's coming from the definition of dot product. E dot B is EB cos theta. So E cos theta will become how much? Just divide both sides by B, magnitude of B. Okay. So this is what it is. So now we have to calculate this. Okay. So this will become the dot product of E, which is I cap plus j cap minus k cap with B, which is 3 I cap plus 4 j cap divided by the magnitude of B. So B was this vector 3 I cap plus 4 j cap. So ये अभी कितना हो जाएगा? इन दोनों का डॉट प्रोडक्ट कितना होगा? 1 into 3 plus 1 into 4 plus minus 1 into 0, because this doesn't have a z component. So that is the numerator, that's the dot product. Okay. Divided by this will be how much? Square root of 3 square plus 4 square, that's the denominator. So this is becoming how much? This is becoming 7 by 5 or 1.4. Okay. So this is this E parallel, or that's the same thing as E cos theta, is the component of E along B in magnitude form, not in vector form, but in magnitude form. Yes, hope this is clear, people. Make a note of this quickly and make sure you understand the steps. Ask me if there's any doubt with this. Okay, so in the diagram, you first understand what we are trying to do. Okay, we are trying to find the component of this vector along this line, that is A parallel, and the component of this vector perpendicular to this line, that is E perpendicular. So because this angle is theta over here, you apply trigonometry here. So what is this base over here? Its magnitude is nothing but E cos theta. So the next thing is E cos theta कैसे निकालेंगे? We calculate it by using the dot product formula. Okay, so this is the parallel component. Now let's come to the perpendicular component. The next thing we want to find out is the perpendicular component in magnitude form. So we know that E perpendicular square plus E parallel square is nothing but E square. Okay, since we know that E parallel is E cos theta and E perpendicular is E sin theta. That's all. Okay. So therefore, E perpendicular can be just calculated as square root of E square minus E parallel square. So E is nothing but magnitude of the vector I cap plus j cap minus k cap. So that is square root of 1 square plus 1 square plus 1 square. So that is root 3. Okay. And E parallel we had just seen was 7 by 5 or 1.4. So E perpendicular is just becoming square root of root 3 whole square minus 1.4 whole square. So that is 3 minus 1.4 whole square. So that is your perpendicular component. Okay, so hope this is clear, people. Now let's come to the second part. In the second part of the question, I want to find out B parallel as a vector quantity and B perpendicular, okay, as a vector quantity. So in iit-jee notation, or as vectors expressed in component form. So let's first understand again what we are doing. So if this is the vector E and this is the vector B, now this time along A's direction we have to find. So this is A's direction. This is the line along which A is lying. Okay. And this is the line perpendicular to A. So here we have to now drop a perpendicular from B onto A's direction. And a perpendicular from B onto the direction perpendicular to A. That is something. So this is what we want to do now. Okay, so we want to find out the component of B which is along the direction of E. So that will be this one. And the component of B perpendicular to the direction of A. So that will be this one. So this is my B parallel and this is my B perpendicular. Okay. So first of all, this is what we are doing now in this question. Now we'll see how to actually calculate it. So remember the vector E was I cap plus j cap minus j cap, and in this the vector B was 3 I cap plus 4 j cap. Okay. So now you can see that B parallel, the component of B along A in vector form, not as a magnitude but in vector form. So that B parallel has a magnitude of B cos theta, but its direction is along what? Along E. So it is this. Okay. So here B cos theta is E dot B divided by mod E this time. Okay. So again from here E dot B you will see is 7 and mod A was root 3. So B cos theta is root 3. Okay. And E cap is nothing but the unit vector of E. So that is nothing but E divided by its own magnitude. Okay. So that is nothing but the vector E, which is I cap plus j cap minus j cap divided by its own magnitude. So that is mod of I cap plus j cap minus j cap. So that is nothing but I plus j minus k divided by its own magnitude, which is root 3. So this is A cap. Okay. This is A cap and this is B cos theta. So now B parallel, which has a magnitude of B cos theta, but its direction is along E, so its unit vector is A cap, is now just the product of these two. So it is nothing but 7 by root 3 multiplied by this unit vector, which is I cap plus j cap minus k cap. जो कि क्या है? It is the unit vector of E, E cap. That is this one. So that is substituted here. And you can see this becomes 7 by 3 I cap plus j cap minus k cap. Or you can also express it like this, that it is 7 by 3 I cap plus 7 by 3 j cap minus 7 by 3 j cap. Or you can even express it like this, that it is 7 I cap plus 7 j cap minus 7 k cap. The whole thing divided by 3. Whichever form you want to express it, it's fine. All these three are correct answers. The main thing is that as a vector, the parallel component is this. Okay. And likewise, we'll now come to the perpendicular component also. First, make a note of this. So make sure you understand all the steps that we used over here. Okay, starting from the concept itself, what we're doing over here. That's in the diagram. right up to the final application. So how we are achieving this? कैसे निकाल रहे हैं B parallel? So in the diagram you can see कि ये जो vector है, ये वाला B का पैरेलल कंपोनेंट, इसका मैग्नीट्यूड कितना है? इसका मैग्नीट्यूड t cos थीटा है, बट इसका डायरेक्शन क्या है? E के लॉन्ग है, सो इट्स डायरेक्शन इज द यूनिट वेक्टर E क्या. So that's why we are expressing it like this, that the parallel component has a magnitude of B cos theta, but its direction is along A cap, so it is B cos theta into E cap. Now B cos theta कैसे निकालेंगे? Definition of dot product से निकालेंगे. A dot B divided by mod A. So A and B were given, so from that you find out A dot B. Substitute these values of vector A and B from here. So dot product you can see is 3 plus 4 plus 0, so that's 7. Okay. And mod A is nothing but magnitude of this vector, which we saw earlier, is root 3. Okay, so that's, whereas what is E cap? It is the vector A divided by its own magnitude. So again, pick up the vector A from here, substitute it here. So that is how we are getting this final calculation. Okay, so note this down and also now try to work out how we will get the perpendicular component in vector form. Okay, people, so this is the parallel component. Now the last thing, how do we find the perpendicular component in vector form? So again, you can see that this was the parallel component of B. This was the perpendicular component of B. So इनका vector sum क्या था? इनका vector sum was nothing but the vector B itself. They were perpendicular, but the sum of these two components is nothing but the vector B itself. That was this vector. So since the vector B itself is the vector sum or the vector resultant of these two, so we can say that the perpendicular component is the vector B itself minus the parallel component of vector. So the vector B itself was 3 I cap plus 4 j cap, and the parallel component we had just calculated above was 7 by 3 I cap plus 7 by 3 j cap minus 7 by 3 k cap. So the perpendicular component in vector form will become 3 minus 7 by 3 I cap plus 4 minus 7 by 3 j cap plus 0 plus 7 by 3 k cap. So that will become 2 by 3 I cap plus 5 by 3 j cap plus 7 by 3 j cap. Or we can also express it as 2 I cap plus 5 j cap plus 7 k cap, the whole thing divided by 3. So whichever way we want to express it, This becomes the final perpendicular component. This one is. Okay, so this is how we find out the perpendicular component in vector form. Okay, so perpendicular component in vector form. So we make use of this over here. Parallel component निकाला है पहले, उसका use करते हैं. Okay, so this is what I wanted to do to begin with today. Do a quick revision of the concept of projections before we get into other things. No, Shikhar, we are not making use of Pythagoras theorem in vector form because we are making use of vector addition or vector subtraction. Pythagoras theorem, remember, applies to sides of a triangle, that to a right angle triangle. But here we are applying vector algebra now, so we are not making use of Pythagoras theorem. Pythagoras theorem का use करते हैं when we are dealing with the magnitudes, because those are nothing but the sides of the triangle. Okay, people, so hope this is clear. So let's come to the discussion on assignment 6 now. So does anybody have a doubt in the first, second or third question? Please let me know by message. Let's come to assignment 6 discussion. Okay, she read question only, very good. Anybody else? Doubts in first, second or third question? Let's start with these. Please let me know, people. Okay. So far out of the first 3 questions, I have received only for question 2. If you have doubt after third question, just wait. Okay, just let me finish. Okay. So question 2, let us start with. So question 2 has given us two vectors. A, which is given as 3i cap plus 4j cap, and the vector B, which is given as 7i plus 24j cap. Now we have to find a vector which is along the direction of the vector E and has same magnitude as B. So we can think of this question like this, that let's say the vector C is this one, such that C is along vector E. So what that means, that C cap is equal to A cap. Now the unit vector of C is equal to the unit vector of E. So basically, if this is the vector E, suppose, then the vector C should be parallel to it or along its direction. You can draw the vector C like this, or we can draw the vector C like this, whatever, it doesn't matter. The important thing is that it's parallel. Okay, so whatever way we draw it, so that is why the unit vector of C will be equal to the unit vector of E. A vector of magnitude 1 along the direction of C should be the same as the unit vector of E. Okay, so that's why C cap should be equal to A cap. That's the first thing we know. Okay. And magnitude of C should be equal to magnitude of B. So that's the same. So since A was given as 3i cap plus 4j cap, so C cap, which is E cap, is magnitude of E divided by mod A. So that is 3i cap plus 4j cap divided by mod of 3i cap plus 4j cap, which you know is 5. So C cap will become 3i cap plus 4j cap divided by root of 3 square plus 4 square, that's 5. So this is the unit vector, and magnitude of C is equal to magnitude of B, which is magnitude of this vector, 7i cap plus 24j cap. So that is square root of 7 square plus 24 square. So that is how much? So that is square root of 49 plus 576. That is square root of 625 or 25. Okay. So mod C is equal to mod B equal to this. So now the vector C should be its magnitude multiplied by its unit vector, because C cap is C divided by mod C. So the vector C itself is magnitude of the vector C multiplied by the unit vector of C, and that's C cap. So that is nothing but the magnitude we just saw is 25, and the unit vector we had seen earlier was 3i cap plus 4j cap whole divided by 5. So the vector C is becoming 15i cap plus 20j. Okay. So this vector has a property that magnitude of this vector is the same as magnitude of vector B, and vector C is parallel to the vector E, because you remember the vector E was 3i cap plus 4j cap. So you can see that C's x component divided by A's x component is equal to C's y component divided by A's y component, which is plus 5. So this is a condition for parallel vectors. This is the condition for parallel vectors. So all this is explained in last time's lecture notes. You can go through that also if required. No, not A and B better. A and C. A and C. That's another way you can do the question. The alternate way you can do the question is that like this, that if you apply the condition that also do it like this, that C is along A or parallel to A. That means that C will be equal to some number into A, where n is a positive number. Okay. So you can write that C is equal to n times 3 I cap plus 4 j cap, or it is 3n I cap plus 4n j cap. And then additionally, once you express this way, mod C is equal to mod B. That means root of 3n whole square plus 4n whole square should be equal to 25. That means n times. So that means n should be equal to 5. So that means that C is 59 plus 22. That's another way in which you can do the question. Both the methods are equally simple. There's nothing difficult in it. So you can also use this kind of logic. Okay, so next we are moving on to the fourth and fifth question, which have been asked as doubts. The list of questions people have been asking. There is fourth question and fifth question, so I'm coming to those two next. Okay, so this is this method where you are seeing that the direction of C is along it. So C cap should be A cap, and the magnitude of C should be magnitude of B. So further, Okay, so hope this is clear to all of you. The alternate method is just it's the same logic, but we have expressed it in a different way. That C is parallel to A. So instead of saying C cap is equal to A cap, we're just saying C is some number into A. So let's say that number is n. So it becomes 3n I cap plus 4n j cap. And then you are applying the condition that magnitude of C is equal to magnitude of B. So this vector's magnitude should become 25 because we calculated earlier that mod B was 25. Okay, so people hope this is clear now. Okay, so moving on to next up, we look at the fourth question. The fourth question is pretty standard. You have to find the angle between two vectors, and one of them is given by the relation I cap plus j cap, and the other one is 2i cap plus 2k cap. You have to find the angle theta, let's say. Yeah, now I'm coming to your question. Don't worry. If somebody else has asked question 4, so I'll discuss. It's not just your questions; other people's questions are also there. So angle theta between vectors A and B. Oh, first question also. Okay, okay. Sorry, Anna. I will come to the first question. Okay, let me finish this. I'll come to the first question. My mistake. I did not see that. Yes, at the first question also. Okay. I'll finish this and we'll come back to the fourth question. Okay. So the angle theta, how we'll find? We'll find by the formula that cos theta is equal to A dot B divided by magnitude of A into magnitude of B. Okay. Because A dot B is equal to AB cos theta. Okay. So अभी देखो यहाँ पे E dot B कितना होगा? E dot B will be 1 into 2, okay, product of x components, plus 1 into 0, product of y components, plus 0 into 2, product of z components. So that is just 2. E dot B is this much, okay. And magnitude of A is how much? Square root of 1 square plus 1 square. So that is root 2. And magnitude of B is how much? Square root of 2 square plus 2 square. So that is 2. So all these three values we will substitute below. So substituting these, we will get cos theta as A dot B, which was 2, divided by mod A, which was root 2, into mod B, which was 2. So this will be half. So that means theta is cos inverse half, which means that theta is 60 degrees. So that becomes the answer for question number 4. So just note this down if you need to, and then come to question number 1. We'll first go back to question 1, then come to question 5. Okay, so hope this is clear, people. Coming to question 1 now. So question 1 is given us two vectors A and B, and then asked to find the angle of A plus B with respect to the x-axis. So what we'll have to do is first calculate A plus B from the given vectors, and then find the direction cosine with respect to the x-axis using the concept of direction cosines. 4i cap minus 2j cap plus 6k cap, and the vector B is I cap minus 2j cap minus 3k cap. Now the question is asking you to find the angle made by A plus B with respect to the x-axis. So what we'll do is we'll first find the resultant. So resultant of A plus B is 4 plus 1 I cap plus minus 2 minus 2 j cap plus 6 minus 3 k cap. So the resultant is 5 I cap minus 4 j cap plus 3 k cap. This is the resultant. So now we can see that for this vector, direction cosine with respect to x-axis is given by that formula cos alpha is equal to x component divided by magnitude. So that over here is 5 divided by root of 5 square plus 4 square plus 3 square. That is nothing but 5 by root 50. So we can say that alpha is cos inverse 5 by root 50, which we can also simplify, or that is cos inverse 5 by 5 root 2 cos inverse 1 by root 2, which is in fact 45 degrees or 5 minutes. But here the answer is given in this form, so you just leave it in this form. This is actually equivalent to 45 degrees or this. So that is the fourth question. That is the first question. Next, we move on to the fifth question. Fifth, seventh, eighth, then 12th, 13th, etc. Okay, people. So hope this is clear. Now move on to the fifth question. Explain it to you. The fifth question is just a direct application of three-dimensional vector algebra. In question 5, just a second, guys. And reshare the screen just a minute. Yeah. So in question 5, just hang on a second. Restart the program. Just wait a second. Yeah. So in question 5, it is given to us that we have three mutually perpendicular forces. Three mutually perpendicular forces of magnitude 3 newtons, 4 newtons, and 12 newtons. We have to find the magnitude of the net resultant force. This thing where the net resultant force is the vector sum of F1, F2, and F3. So now, since these three forces, F2 and F3, are mutually perpendicular, because they are mutually perpendicular, therefore, suppose F1, or suppose we take our x-axis, we have defined, we define x-axis along F1 and y-axis along F2, then it automatically implies that F3 is either along z-axis or negative z prime axis. दोनों में से एक के लॉन्ग होगा. Okay. So therefore, if we assume that F1 is 3 I cap and F2 is 4j cap, 3 I cap in newtons, and F2 is 4j cap in newtons, then automatically, because they are mutually perpendicular, F3 will either be plus or minus of 12. It will have to be in one of those directions. So therefore, the net force, the sum of these three, will be 3 I cap plus 4j cap plus 12k cap, or it can also be minus 12, depending on which directions. Okay, so therefore, the magnitude of this will just become root of 3 square plus 4 square plus 12 square. So that is 9 plus 25 plus 144. So that is square root of, 9 plus 16 plus. So that becomes 144 plus 25, which is 169. So that is 13. Okay. So the magnitude of the net force becomes 13 newtons. So this is the fifth question. Okay. Now moving on to 7th and 8th. Then we come to 9th, 12th and 13th also. So next we move on to the seventh question after you finish this. All right, let's move on to seventh question. It's a pretty direct question actually. So in seventh, what is happening is two vectors are given to you with one unknown quantity c, and you have to find the condition for them to be perpendicular. So in question 7, vector E is given to us as ci cap minus 4j cap plus 2k cap, and B is given to us as 2 4c, so 2y cap plus 4j cap plus c. Now we have to find the value of c such that A and B are perpendicular to each other. So this is very simple. A dot B should become 0. So that in turn implies that apply the dot product. So C into 2 plus product of Y component, so that's minus 4 into 4, plus product of Z components, so that is 2 into C should be 0. This is the perpendicularity condition. When two vectors are perpendicular, the condition is that their dot product should be 0. So 2c minus 16 plus 2c is equal to 0. So that will give you the value of c as 4. This should be your answer. Okay, so quickly note this down if you haven't done this question. And then moving on to 8th question. So in the 8th question, you have to find the unit vector which is perpendicular to the resultant of A and B. So first of all, vectors A and B are given to us. And then we have to find which of these unit vectors is perpendicular to it. So E is e-tie cap minus 6j cap. B is e-tie cap plus 8j cap. So we have to find the unit vector perpendicular to the sum of A and B. Okay. Meaning of unit vector is it's a vector of magnitude 1. A unit vector by definition is a vector of magnitude unity of 1. That is the meaning of unit vector. So the general notation is cap. So mod of n cap is 1. So now you can see that first of all a plus b is becoming 16 I cap plus 2j cap. Okay. So if this unit vector is n cap, okay, so that means that n caps dot product with a plus b should be equal to 0. That means n caps dot product with 16 I cap plus 2j cap should be 0. So next thing we will do is we'll check the options. Okay. Or we can, so let us say n cap is some x I cap plus y j cap, where x and y we want to calculate. So first of all, n cap magnitude should be equal to unity. So that means root of x square plus y square should be equal to 1, which means that x square plus y square should be equal to 1. That's the first thing. And secondly, n cap should be perpendicular to a plus b, or that means the dot product of n cap with a plus b should be 0. So that means this x I cap plus y j cap, इसका dot product with a plus b, which we just saw was 16 I cap plus 2 j cap should be 0. So it should be 16x plus 2y is equal to 0. So this, now we have to solve these two equations. Okay. So solving equation 1, which is that x square plus y square is equal to 1, and 2, which is that we can express this as 8x plus y is equal to 0. So substitute this here. So we get x square plus y, which is how much? Minus 8x the whole square is equal to 1. So we will get 65x square is equal to 1. That means x is equal to plus minus root of 1 by 65, or plus minus 1 by root 65, and y is equal to minus 8x. So that means y is equal to either minus or plus of 8 by root 65. So that means n cap is either, when we take x as 1 by root 65, accordingly y is minus 8 by root 65 j cap. Okay. Or n cap is when we take this one with minus sign, so this one comes with plus sign. So it's minus 1 by root 65 I cap plus 8 by root 65 j cap. So both of these are unit vectors which have the property that they are perpendicular with a plus b. Now you can see the answers in the options given, one of them is given, so that is this one. So that becomes the correct answer. So this is the direct way of solving this. Okay. Now one more thing you could have done is, since the options were given, instead of calculating, you could have directly applied this condition for the options. So one more thing you could have done is here, just check from this step onwards. Just check this for the options given. Check for options A, B, and C. So you would have seen that you would have got the correct answer with one of them. So you would have seen that correct answer would have come with option E. Whereas B and C will not give you the dot product as 0. Oh, sorry. The correct answer will be C. The correct answer will not be E. Now, the reason for that is that the option A that is given to you, which is I cap minus 8 j cap by 65, this is not a unit vector. Okay. So, this is not a unit vector. So, this magnitude is not 1. Okay. You can check the magnitude of this. इसका magnitude क्या आ जाएगा? 1 नहीं आएगा. इसका magnitude this will come out to be root 65 by 65. So that's 1 by root 65, which is not equal to 1. So that's why this is not a unit vector. Whereas option C, it is correct. Option C में the unit vector is given as I cap minus 8 j cap by root 65. So you can see that this has magnitude equal to 1 and dot product with E plus B 0 देता है. So that is why C is the correct option, or it is this one. So you can solve directly also, but you can also solve by just checking the dot product condition on the options. That's the easier way of doing this question. Okay. So just complete noting this down and then do the 9th question yourself. I'll just explain to you, but try to do it yourself because it's a direct question. It's a formula based question. We just apply the formula for direction cosines. Okay, so complete the 9th one, try to get it yourself, and then we'll also discuss question 12 and 13. Oh, also 11, I think. Yeah. So after 9th, we'll do 11, 12, and 13. Try to get the 9th question yourself. Okay, so people, hope you finished the ninth question also. Ninth question, you have to just find the direction cosine. So it's a direct question. Vector E is given to us as 2√2 I cap plus 2 j cap minus 2 k cap. Okay. So cos alpha is Ex by E. So the magnitude of the vector you can see is the root of 2√2 ka whole square plus 2 square plus 2 square. Okay. So that is 8 plus 4 plus 4. So that is 4. Okay. So this is 2√2 by 4 or 1 by root 2. Cos beta is Ey upon E, that is 2 by 4 or half. And cos gamma is minus 2 by, it's Ez by E. So that means substitute as minus 2 by 4 or minus half. So these are nothing but the direction cosines. Okay. These are the direction cosines which are denoted by cos alpha, cos beta, and cos gamma. So that's it. That's all you have to do with that. That's question 9. Finish this quickly and move on to question 11. वो भी इसका application है, but just using the reverse of this. In question 11, direction cosines are given to us. Direction cosines are 3 by 13. Minus 4 by 13 and 12 by 13, and the magnitude of the vector is given to us as 65. Okay. So the vector E we have to find out. So use the formula cos alpha is the x component divided by magnitude. So that means the x component can be expressed as this. That is 65 into 3 by 13. That is 15. Okay. Similarly, cos beta is Ey by E. So that means we can express the y component as magnitude into cos beta. So that is 65 into minus 4 by 13. So that will become minus 20. And similarly, the z component will come out to be magnitude into cos gamma. So that is 65 into 12 by 13. So that's 60. So the vector E can be expressed in component form as 15 I cap minus 20 j cap plus 16. So this particular vector will have the properties, that is cosine, direction cosines are those values 3 by 13, minus 4 by 13 and 12 by 13, and its magnitude will be 65. Okay, so this means. So finish writing this and next move on to the 12th question. We'll discuss that next. Okay, let's move on to the 12th question next. So in 12th question, what is happening is E dot B is given to us as okay, good, better. Minus 20, very good. And magnitude of E is equal to 4. Magnitude of B is equal to 5. So we have to find mod of A plus B. Yes, Ankita, your answer is correct. Okay. Very good. So what we have to do here is we have to use this definition that E dot B is EB cos theta. Okay. So that means 4 into 5 into cos theta is equal to how much? It is minus 20. So that means cos theta is minus 1 or theta is 180 degrees or pi degrees. Okay. So that means mod of A plus B will actually become magnitude of B minus B. Okay. Because theta is 180 degrees. So that will become mod of, that's 1. Okay. Or if this doesn't strike you immediately, just use the formula. The triangle law. So in this substitute E as 4, B as 5 and theta is 180 degrees. So that means cos theta is minus 1. So you get this as root of 4 square plus 5 square plus 2 into 4 into 5 into minus 1. So you get the answer for this. You get this as 16 plus 25 minus 14. So you get this as, but this is too lengthy. You can see all these steps are not really needed because it should strike you that the moment this is the case, this is this. This is from the result of triangle law. You remember triangle inequality also. So होता था ना that mod A plus B का minimum value क्या होता है? It is the magnitude of the difference. But this happens when theta is equal to 180 degrees. So from this you should remember this case. Similarly, maximum value क्या होता है? A plus B. And this happens when theta is equal to 0. So here the moment you see that this is the case, you are getting theta is this, you know that this will be the case. So you have to be alert while doing these type of questions so that you can avoid doing extra calculation. Next, move on to the 13th question. So in question 13, it is given to us that E plus B is perpendicular to E minus B. And it is given to us that mod A is equal to 5. So we have to find how much mod B is. So you can do this question again by two methods. One is we can make use of dot product. Using dot product. If two vectors have dot product equal to 0, that means they are perpendicular. So we can say the reverse of that. So therefore, if capital A plus capital B is perpendicular to the vector capital A minus capital B. That means that their dot product, that is the dot product of this vector and this vector, should be 0. So this is a very simple way of solving it. Now open this bracket by distributive property of dot product. So A dot A minus A dot B plus B dot A minus B dot B is equal to 0. Now by definition A dot A is A square, and by definition A dot B is the same thing as B dot A. So this term and this term cancel. So here we are using the commutative property. Using the commutative property of dot product. So we are equating this one with this. So we have A square minus B square is equal to 0, which generally means that A is equal to plus minus B, but here we just take A equal to B because A is magnitude of A. So it's a modulus. So it cannot be a negative quantity. And B is magnitude of vector B. So it's a modulus. So that also cannot be a negative quantity. So that's why it just means that A is equal to B. So that means the magnitude of vector B is becoming 5. So the magnitude of vector B. So this is making use of the scalar product or dot product concept of perpendicular vectors. Now we can also do this by using component algebra, and I'll come to that next. But first note down this method. Yeah, so if any doubt, please ask me. Yes, we can also use parallelogram method to do that also. So we can use the fact that which type of parallelogram has perpendicular diagonals. It's a rhombus. Correct, Shikhar. That's very good. So you can even take that as your method too. So we can, in fact, method 2 we can use parallelogram law of vector addition and subtraction. Okay. So we can see that if A and B are like this, drawn from a common origin, so if we draw a parallelogram like this, then this primary diagonal of the parallelogram drawn from the common origin to the opposite side is the resultant sum, whereas the secondary diagonal, yes, we have done this in the last class. This represents the difference. Okay. Now you'll note something important here, that in a parallelogram, geometrically, see that geometrically the condition for the diagonals to be perpendicular is that it should be a rhombus. Geometrically, the condition for the diagonals of a parallelogram to be perpendicular is that sides are equal. That is, this is 90 degrees only if this side is equal to this side. Or basically the parallelogram should be a rhombus for the diagonals to be perpendicular. That immediately tells you that diagonals are a plus b and a minus b. So if this is the case, it implies that mod A is equal to mod B. Yes. Perpendicular diagonals implies that the sides are equal. So this is a more direct way of understanding the question, provided you remember parallelogram law statement and remember the special case of rhombus. Remember the special case of rhombus, that the diagonals bisect each other perpendicularly. Yes, at that point of time when we had discussed parallelogram law, I told you this is one of the special cases, so you can understand it that way also. So you can just remember this case like a theorem. Provided you go through your notes and you go through that section, you will remember this as a theorem. So then you know this question directly. Okay. Now let's also understand this question by component algebra method, just as an additional practice. It's something interesting. We can also do this by using component algebra. Okay. So given that A plus B is perpendicular to A minus B and magnitude of A is equal to 5. Let us take the x-axis along E plus B and the y-axis along E minus B. Because we are free to select x and y whatever way we like, as long as they are mutually perpendicular. So because it is given that this vector is perpendicular to this, if we can just assume our x-axis is taken along this direction and our y-axis is taken along this direction. So in other words, we can assume that the vector A plus B is some magnitude x but into I cap, and the vector E minus B is some different magnitude in the direction perpendicular, because they are perpendicular. They are given to be perpendicular. So now from this we can say that if we just add equation 1 and 2, that will give you that 2a is equal to x I cap plus y j cap, or the vector A is x by 2 I cap plus y by 2 j cap. If you subtract the two equations, that will give you 2b is equal to x I cap minus y j cap. So that is give you that the vector b is x by 2 I cap minus y by 2 j. So now these two equations, they are showing you that magnitude of E is equal to magnitude of E is equal to square root of x square by 4 plus y square by 4. So therefore, given that E is 5, it means that B must be also equal. So this is yet another way of solving. Okay, but obviously the simplest of all these methods is if you directly remember the result from the parallelogram law, that the condition for diagonals to be perpendicular is that the sides must be equal. That is, the parallelogram must be a rhombus. Then you don't have to do any calculation. Then you can see that the question is direct. In fact, that is one of the reasons why we study parallelogram law as a separate law, because it helps us do these sort of comparisons and analysis directly. Okay, people, so hope all this is clear. So the problem solving we've done in today's class is a little bit more heavy, because it is to do with things like projections and application of dot product mostly, which is the slightly more complicated part of vector algebra. So make sure you revise the questions we've done in class today very thoroughly once. Okay. Apart from other things, I will be giving you some assignment again and all that. Now we come to the last operation in vector algebra. So we are coming towards the end of vector algebra. Another couple of lectures, then we'll be finishing up vectors. So the last operation we'll study in vector algebra, you might have seen if you're going through the module, is the operation of cross product. Or it is also called vector product operation. Okay. So the symbol used for this operation is the cross sign. Okay. So this is read as the cross product of vectors E and B. Cross or vector product of E and B. So this is just the symbol. Okay. I will come to the definition of it next. So just make a note of this part first. So this symbol is distinctly different from the dot product. You can see that dot product is denoted with a dot sign. So this is scalar product. But when we put a cross sign in between two vectors, it is called the cross product or the vector product. Okay, now let's come to the definition. So the definition of cross product is given by A cross B is equal to a vector quantity whose magnitude is AB sine theta and whose direction is given by n cap. So E cross B is a vector, okay, such that its magnitude, that is mod of A cross B, is given by AB sine theta, where of course E is nothing but magnitude of the vector E, B is magnitude of the vector B, and theta is the angle between them. And additionally, the direction of A cross B is along a unit vector n cap, such that this unit vector n cap is perpendicular to both vectors E and B, and is given by what we call by right hand palm rule. So the definition is having two aspects to it. Okay, one is that the magnitude of A cross B is given by the formula EB sin theta, and secondly, the direction of A cross B is given by the unit vector n cap, and that is a unit vector such that it is perpendicular to both the vectors A and B. So we'll understand more about it with examples. First, just note this down. Okay, so let's understand first of all what is the right hand palm rule. To find n cap, the direction of n cap. तो उसमें क्या करते हैं, for E cross B, what you do is you place your right hand such that your thumb points along the vector E, and the four fingers point towards the direction of B. Okay. Now, whichever direction the palm faces, okay, that is the direction of n cap. So let me take you through these steps with an example. So this is the right hand palm rule. So for example, if this is the vector E and this is the vector B, now what I'll do is physically I will place my hand, okay, such that I'll place my right hand such that it's like this, it's placed on this, so my thumb is pointing towards E, and the four fingers are pointing towards B. They are pointing in the direction of B. So I'll place my hand over here such that that happens. So when I place my hand like this, you will see that your palm, you do it, place it on the screen, you will see your palm is facing towards you. This is your palm. So your palm is facing outwards, is facing outwards from the plane of the screen. Okay. So therefore, n cap is a unit vector coming outwards. It's coming straight out of the plane of the screen. Then you place your left hand ulta beta. If you place your left hand like this, you will see that your knuckles are facing towards you, not the palm. It's if you place your right hand on this. Place your right hand on the screen, the way I placed it here. You'll see your right hand palm is facing towards you. If you place your left hand like this, then your palm is going into the plane. No, the palm is not coming out. If you place your right hand, then you'll see your palm is coming out. Have you understood it, Anshu? You place your right hand like this on the screen, then your palm is facing towards you. If you place the wrong hand, you will get the opposite direction. You will get the left-handed rule. We don't follow left-handed rule. We follow the right-handed rule for the direction of engine. You understood this now? Okay. So just note down these steps first and note down this first example. Then we'll practice this with few more examples so that you get this correct. So whenever we draw two vectors A and B in the plane of a paper or in the plane of a screen, the n cap will either be coming out or going in. So how do we decide whether it is coming out or going in? By making use of the right hand palm rule. Okay. So the first step is that you have to place your hand such that you can extend your thumb, your right hand thumb, towards the vector A and your four fingers towards the vector B. So on placing your hand in such a way, you will see that you will have to place your right hand on the paper or on the screen in whichever you're drawing it, such that either the palm will be facing towards you or your knuckles will be facing towards you and the palm is actually facing into the paper or into the screen. So accordingly, the direction of n cap is either coming out of the plane or going into the plane. Do your option with it, like this. So let's understand this with some examples. So indicate the direction of A cross B in each of the following as going into or coming out of the plane of the screen. Okay, this is what we have to do in the question. I'm giving you some examples. So part 1, let us say vector E is like this and vector B is like this. So you have to now apply the right hand palm rule. Okay, and tell me which of the cases it is. Is coming out or going in? Second one, that E is like this. Vector B is like this. Third one, So in each one of these, now you have to tell me clearly whether my A cross B is going into the plane or coming out of the plane. So just use the right hand thumb rule. Just try this out and send me the answers, people. Just in each one of them, part 1, part 2, part 3, and part 4, you have to tell me, it's coming out or going in. Yeah, Idanshu, correct for the first one. Varin, correct. All 4 correct, Varin. Shikhar, correct. Rudra, correct. Okay. Priyank, correct. Yeah, Dhrumi, correct. Pratham, correct. Okay. So you will see. So let me just put the answers up. So in this case, it is coming out of the plane. Okay, because what is happening is you have to place your fingers like this and your thumb like this. So you see that your palm is facing outwards like this when you place your right hand like this. But in this case, it is going into the plane. Why it is going into? See, you place your thumb like this and your fingers like this, and you will see that your hand is placed such that your knuckles are here. The palm is into the plane. This is the knuckle side. So that means your palm is into the plane, going into the plane. So you place your hand like this. Now again, for example, in fourth case, you place your thumb like this and your fingers like this. So you'll see that your palm is facing outwards. This is your palm. So it's outwards. It's coming out of the plane. But in this case, you'll have to place your thumb like this and your fingers like this. So again, you'll be seeing your knuckles. You will be seeing your right hand knuckles. So this is again into the plane. Okay, so that's why the answers are first case coming out, second and third going in, and fourth case again outwards. Okay. So hope this is clear to all of you. Okay, so now quick example more and then we'll wind up for today. Suppose now I have my XY axis defined like this. So you know that in this diagram, the Z axis is coming out of the plane. So Z axis or K cap is coming out of XY plane. The minus K cap is going in. So in that situation now, suppose my vectors E and B are drawn like this. E is of magnitude 10 units, B is of magnitude 5 units, and this angle between them is 120 degrees. Then find, first of all, magnitude of A cross B. Then second, direction of A cross B. And then finally, A cross B in vector form. Okay, so just wind up with this question. We will try this out. Very good, that's correct, Varun. So you can see here that the first part, the magnitude of A cross B is given by the formula dB sin theta. So that is over here is equal to 10 into 5 into sine 120. Now sine 120 is the same thing as sine 60. Okay. So that is nothing but root 3 by 2. So this becomes 25 root 3. Root 3 square units. this becomes my magnitude of A cross B. So here I have actually made use of the fact that sine 120 equals to sine 180 minus 120, second quadrant formula. Equals to sine 6. I made use of this formula also. Okay. So that's the first part's answer. Now what about the second thing? What about the direction? Is it going in or coming out? You see it's coming out. You have to place your thumb like this and your right hand fingers like this. So your palm is facing this way. Okay. So it is outwards. E cross B is outwards. So that means what is the unit vector? Is the unit vector coming out? So that will be k cap. So now that's the second thing that we know over here. The direction is coming out. So that also means that the unit vector is nothing but k cap, z axis. Because coming out wala direction kya z axis. So finally, what I'll express the vector as, the third part, I'll express the vector A cross B as its magnitude, which was AB sine theta, into its direction n cap. So AB sine theta kitna hai? That 25 root 3. Or n cap actually kya hai? It's nothing but the unit vector along the z axis. So this becomes my final answer. So in vector notation, the operation A cross B gives us 25 root 3 units squared k cap. That becomes the answer. Okay, so this is clear to all of you people. Okay, good. So people, that's it for today's lecture. Okay. I will be sending you some questions to do and all that. And next lecture, we will look at cross product in more detail. And most importantly, we'll look at cross product for vectors given in component form. That is the formula of a cross product of two vectors when the vectors are given in terms of ax I cap, ay j cap, like that. Like we're done. Yeah, homework, I will be sending you something. Okay. This week, you will also be doing some questions from your worksheet, from your module. So I'll be sending you a list of questions to do from exercise 1, particularly from your module. Okay, so try those out, we'll discuss. That's it, thank you people. Okay, and stay safe. Okay. Bye people, that's it from my end. Dhrumi, to answer your question, in that particular example, the last one, we use the right hand thumb rule to show that the vector n cap was coming out of the plane. Okay. अभी जैसे हमने xy axis लिया, उसके हिसाब से what is the direction coming out of the plane? It's the z axis. So that's why a unit vector coming out of the plane becomes nothing but k cap. So that's how we got that n cap was equal to k cap. Okay. Anyway, don't worry about this. We'll discuss about this more in the next lecture.